Hello, welcome to the tutorial video of ANOVA, performing ANOVA in Excel. Today I'm going to show you how can we perform ANOVA simply in the Excel. This is the data of grain of wheat that is shown under heat stress environment, and to compensate the yield loss in heat stress environment due to heavy hot wind, we have applied 7 different treatments to know the efficacy of potassium nitrate on so as to compensate the yield loss in heat stress environment. So to perform ANOVA in Excel, you have to arrange the data in this pivot style. This is typical pivot style. You can where we have placed replication here and treatment here. You can interchange it, and And to perform ANOVA, you have to go to the data section. We have to go to the data section and click on the data analysis and click on ANOVA single factor. There are different options you can select. If this is the simple example of RCBD conducted on the field, so we have to select ANOVA single factor. The data analysis tab is not generally open defaultly on the Excel, so you can check on different tutorials in the YouTube and you can open it easily. So to check the input range, we have to select the input range. To perform ANOVA, you have to select the input range. This is our input range. We want to test whether there is any significant difference among treatment is or not. So we have to select this input range, and the input range is grouped by rows. As we can see, this is grouped by rows. Defaultly it is grouped by columns. If we are testing the significance difference among replications, which is not generally practiced, then we have to select it column because the data are arranged in column. So, but we want to know the difference, there is difference in treatment or not, so we have to select row because the data is placed rowly. And we have the label on the first row. We can see that label in the first column T2 T7, T1 to T7, and we want to place the output in the new worksheet in the sheet 1 or sheet 3. And after selecting all this is the input range. This is the group by row, label in first column, yes. Alpha level of significance 0.05, yes. Then enter OK. After clicking OK, you will get another worksheet, sheet 4, in which you can summarize the data. We can see we had 3 replications, so count of each treatment is 3. This is the sum, this is the average, this is the variance. This is the simple descriptive statistics you can see here and confirm from this sheet. And to know whether there is any significant difference among treatments or not, you have to play with this F value and P value. The simple way to interpret this is through the P value, and for that you can do P value multiplied by 100. The value that comes after multiplying the P value with 100 means that in this case the 79% null hypothesis is getting true here. It means that 79% of the null hypothesis is getting true. So we have to reject the alternative hypothesis and we have to conclude that there is no significant difference among treatments. In any ANOVA, the null hypothesis is there is no significant difference among treatments. If we are performing the ANOVA within replications, then we have to select the replication, go to data analysis, ANOVA single factor, OK. Input range is our replication. Then this is grouped by columns, and there is label in the first row, alpha level of significance 0.05, enter OK. Then you can see this between the F value is 0.09. it means that equal to 0.09 multiplied by 100 means 9%. Not the null hypothesis is getting true here by 9%. So to accept the alternative hypothesis or to conclude there is significant difference among replications here, because we are performing this in the replications, you can see degree of freedom 2, degree of freedom means n-1. We had 3 replications, so degree of freedom will be 3. Degree of freedom will be 2. So to conclude that there is significant difference among replication, this value must be less than 5 or this value must be less than 0.05. Only in that case the alternative hypothesis will be accepted, or we can conclude that there is significant difference among treatments. In this sheet where degree of freedom is 6, it means that we are dealing with the treatments this is clearly shown by the descriptive table. The between groups means between treatments, and the probability of null hypothesis getting true is 79%. So we can clearly conclude that there is no significant difference among treatments here. So through the conclusion we can say that application of potassium nitrate on wheat under heat stress environment will not have any significant difference in yield. So there is no any importance, or there is no any benefit of wasting time by performing potassium nitrate application in this trial or in wheat to reduce the yield loss that is caused by heat stress. And this is the simple tutorial video. If the p-value is less than 0.05, then it is known as significance. Yes, there is difference. If there is less than 0.01, then it is known as highly significant. If the p-value is less than 0.001, we can say it is very highly significant. This must be less than, and less than. The p-value must be less than this. If the p-value is greater than this, we accept the null hypothesis. That means that there is no significant difference in treatments. And to proceed further, we have to consider BC analysis, and BC analysis would not be good here as well, because the application cost and the labor cost will increase. So control is the best, or no application is the best option here. We can conclude that. Thank you. This is the simple example of ANOVA. If you want the detail of the ANOVA, you can check the another video to get informed about the p-value and the analysis of data through variance, analysis of variance in Microsoft Excel. You can check the link on the icon. Thank you.